we are, last question of the benchmark quiz. Question number 20. It says the graph of y equals 3 to the x is shifted to y equals 3 to the x plus k to make the graph below. What is the value of k? So we're either adding on a -2, a -1, +1, or +2 to our y equals 3 to the x value. Now, if you remember from our discussions, anytime we add a number away from the x, so it's sort of outside the parentheses, if you will, if you add a number on the end of your expression, then that is going to shift the graph up or down. Depending on if you add a positive, it'll move it up. If you add a negative, it moves it down. So this was the original equation, y equals 3 to the x. We need to know, did it move up, did it move down, and how much? And that'll tell us the value of k. So what I want to do is just look back here at a quick table of values. Okay, so if we look at this, if x was 0, if we take an x of 0 and we plug that into the function y equals 3 to the x, alright, then that means y will equal 3 to the 0, and anything to the 0 is equal to what? Do you remember? Anything to the 0 is equal to 1. Alright, now we just simply realize this is exponential, so that means we should see a pattern of where the numbers are multiplying by 3 each time, since that's our main number here. So let's see, 3 to the 1, if I plug in 1, that gives me 3. If I plug in 2, 3 squared gives me 9. And let's look, 1 times 3 is 3. 3 times 3 is 9. And then if I do it again, 9 times 3 should give me 27. Whoops, wrote that wrong. Times 3 should give me 27. And we see that happening. 3 to the third is in fact 27. And it should make sense. This 3 to the first, 3 to the second, all we're doing is multiplying by another 3, so we're increasing the exponent, because we're just adding on another time where we're multiplying by 3. So, we see this pattern. It looks like when x is 0, the starting value, the y value when we start, is actually going to be 1. So if I was to look at a graph, that means this graph, when x is 0, I've got a point at 1. If I go over to 1, it's now up to 3. If I go over to 2, it would be up to 4, 5, 6, 7, 8, 9, somewhere way up here. And if I go over to 3, it's going to be at 27, so it's going to be way up, probably up above the table here. So what we see is this pattern where it just comes out like this, and then turns and just begins going up. So we see this smooth curve. Alright, mine was a little bit sloppy in how I drew that, but it's a nice smooth curve, passes through 1. Now, another way we could have figured out where it starts is just looking at the equation. If you remember, exponentials usually have this form: y equals some number a times another number b to the x power. The number that's right beside the x, that we're raising to the power of x, this is our rate that we multiply by. The number in front, this is our starting value, and I'll just abbreviate that SV. So b is the rate we multiply by, a is the starting value. But if we look in this equation, here's the number beside the x. There's no parentheses, but we could put some around it. It's not a problem. So this is the rate. Notice it looks like we're missing a starting value. We've talked about this several times in class before. If there's no number in front of something that we're multiplying, what number could we really put there? Well, we could put a 1, because 1 times anything is just going to remain itself, and usually we drop the 1. But it's actually, even though we don't write it, it's still technically like we have a starting value of 1 written out front. So if the starting value is originally 1, now let's just look at the new graph and see where it's now located. So it should have crossed at +1, but it's crossing now at -1. So it started up here, now the graph has been slid down. So I know I need a negative number, so I can cancel out C and D. And if it should have crossed at +1, and now it's down at -1, how far down is that? Well, we just go down 1, 2. So we've gone down a place of 2. That means the number that was added on to the end of the graph must have been -2 to take us from the original graph, which isn't shown, to this new graph that is. So that's question number 20. Talks about shifting a graph up or down by adding a constant number on the end. And again, all we did is found the original starting value, look at where the new starting value is on the graph, and just see how far it was moved down. So that's number 20. Correct answer was A. Hopefully you got it right. If not, hopefully you understand it now. And if you have done all the other problems, you are now done. So hopefully this helped you review quite a bit of material from the second half of the year. And what I want you to do now is just make sure you have all the problems worked out from the ones you missed, and then make sure you bring that work back into me in class tomorrow. So hopefully this helped. And if you have any more questions, leave a comment or just come talk to me at school. And good luck on your